working on, today we're going to be working on perpendicular and angle bisectors. How can you describe the set of points equidistant from the endpoints of a segment or from the sides of an angle? We're going to prove and apply theorems about perpendicular and angle bisectors. Our key terms are equidistant and locus. Alright guys, so first up, when a point is the same distance from two or more objects, the point is said to be equidistant from the objects. There's this little root word again, prefix if you will. Equis, yeah, meaning equal, right? Third time we've seen it in 2 days. It's meant the same thing every time. Equilateral, equiangular, equidistant. All means equal. Okay? So, this is going to come up today in certain of our theorems about triangle congruence, and specifically about angle and perpendicular bisectors. Okay? Now, a locus is just the set of all points that satisfies a given condition. It says the perpendicular bisector of a segment. Here's how you can define that. The locus of points in a plane that are equidistant from the endpoints of the segment. We're going to put those words and give them more meaning throughout the day today. So first thing up, first thing is going to be perpendicular bisector theorem. Okay? Yes, you need to write down your perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, it is equidistant from the endpoints of the segment. I'm going to explain these in a second. I would write the converse as well. The converse is if a point is equidistant from the endpoints of a segment, it is on the perpendicular bisector of the segment. I will explain those two in just a second. Alright, so this first theorem, if a point is on the perpendicular bisector of a segment, it's equidistant from the endpoints. Okay? I'm given this little thing that says that XY and AB are perpendicular, that YA is congruent to YB. Okay? That means that XA is congruent to XB. Right? So here's the thing that I think you got to understand, so that you really understand this. Any point on this line, on line L, any point on this line is going to be equidistant from A and B. Okay? All those points have to be equidistant. I got that? Because it's on the perpendicular bisector. Down here, it's just the converse. Okay? It says if a point is equidistant from segments, anytime I've got lines intersecting and a point's equidistant from segments, then that point is the perpendicular bisector. So you can go ahead and conclude that AY is congruent to YB, and that there's a right angle that gets formed there. Alright, check it out. Let's do this one real quick. First up, I'm given the following information. I'm trying to find what is BC. That's what I'm trying to find. Well, if A to B is 38 and A to C is 38, hold on. Here's what I conclude. I conclude that AD is the perpendicular bisector of BC. So BD has to be congruent to BC. Okay? Got me? And if DC is 12, then BD must also be 12. And the total of 12 plus 12 is 24. Okay? See how easy that is? Very basic. Yeah, it's basic congruency. Okay? I've taken you from triangle congruence down a little bit. Now we're down back to the easy stuff. Alright? Alright. Let's do this one. All of a sudden, I say, hey, time out. I want to know what TU is. And I'm given this information. T to W is congruent V to W. This is a 90-degree angle. That tells me that UW is the perpendicular bisector of TV. Okay? And then I can use my theorem and say, if UW is a perpendicular bisector, then UT has to be congruent to UV. And if those expressions are congruent to each other, let me do that. If those expressions are congruent to each other, and I need to solve for x, I'll set them equal to each other, and then solve for x. Okay? This goes back to a principle I've tried to emphasize over and over again about this class. We do the same thing, really. We're at 8 weeks now. How long have we been setting expressions equal to each other because they're congruent? About every day. The days we don't do that, what do? Well, we set them supplementary, make them add together to be 180. There's a couple instances where we've said, well, the angle degrees are going to be 60, right? But this class isn't so much about understanding how to solve from here, right? It's about when do I set things equal to each other, when do I make them supplementary, right? That's the basics of this class, okay? So I expect everybody knows how to do this. You set these equal, solve for x, get your answer. Apparently it'd be 6.5. Plug it into the expression. Bibbidi bobbidi boo. Okay? Everybody with me on that? Yep. Alright. Next I switch from perpendicular bisectors to angle bisectors. Okay? Angle bisector theorem says if a point is on the bisector of an angle, then it is equidistant from the sides of the angle. And the converse says if a point in the interior of an angle is equidistant from the sides of the angle, it is on the bisector of the angle. Y'all write it down, then we'll talk about it. Here we go. So check it out. Here's what this says. It says if PC is the angle bisector to APB, what does an angle bisector do? Bisects an angle, thank you, by doing what to it? Splits it in half. And when it splits it in half, it creates two congruent angles, right? Okay, y'all got me? Those are two congruent angles. Those are two congruent angles. You can go ahead and conclude that from any point on the larger angle to a point on that particular bisector, they are equidistant to each other. Okay? So if I wanted to create right here, I could do it as well. See that? And those points would also be equidistant. Notice the right angle that's formed. Right? Down here, if a point in the interior of an angle is equidistant from the sides of the angle, it is on the bisector of the angle. Basically, this says this. You see the right angles, you see the congruency, you can go ahead and conclude that these angles are congruent to each other. Time out. We'll see how much we've learned this week. If I tell you that AC is congruent to CB down here, how is triangle, is triangle APC congruent to triangle BPC? If it is, how? Is triangle APC congruent to triangle BPC? And if it is, how?
Is it the CBC?
It is. And what did you jump to right off the bat? Say it again. He jumped straight to CPCTC. What's wrong with that? Yeah, it comes after I do what? One of my 5 congruency theorems, right? My question is, which congruency theorem am I going to use here? Hypotenuse leg. Because I'm dealing with reflexive property, PC is congruent to itself. What kind of triangles are these? Right triangles. Hypotenuse, congruent on both triangles. A leg, congruent to both of them. After I've used hypotenuse leg, if I said, is PB congruent to PA, you could say yes, because CPCTC. Okay? So that's the difference in using CPCTC. You've got to wait until you've used your triangle congruency. Good job, class. All right. Here we go. Find the measure of BC. What is it?
7.2.
Real easy, right?
Yeah.
All you got to look for is this. Right there. If those angles are congruent, it's an angle bisector. If it's an angle bisector, any points on the larger angle that connect to the bisector are congruent to each other. BC is congruent to DC if DC 7.2, BC 7.2. How about here? Find the measure. If EFH, find the measure of EFH. I'm trying to find this angle measurement right here. Given that EFG is 50. So the big angle measurement is 50. Well, 25 would make sense, right? The only thing you got to check. Right angles, congruent lengths, right? Then you know it's an angle bisector. Angle bisector splits the big angle in half. Half of 50 is 25. Any questions on that? Much easier than what we've been doing, right? Okay? Alright. Y'all do this one. Then I'll give you... y'all do that one first. Take about 2 minutes, see if you can figure this out. Y'all are done? So, here we go. What'd you get? What?
No, it's option play.
Find the measure of x, y, z. What'd you get? One what? How'd you get it? I got big ears. I got big ears and I can't hear you, so.
W and Y equals 180 degrees, which is right angle. Got that, and I found out why it was, or, no, 27. What was it?
Hold on, Muse. Hold on. Let's start with what I know right now. I know right now that WYX is 63. I'm sorry, WYZ is 63. Okay. I know that's 63. I know this is 5.7 and this is 5.7. If those are congruent, what's true about these angles? They're congruent, which means that this angle is 63. So the entire angle is the sum of 63 and 63. So what is that? 126. Okay? 126. Alright, one more thing, then I'll give you a small break. About 3 minutes. Okay. S is equidistant from each pair of suspension lines. What can we conclude about QS? What bisector?
P O Q. Triangle PRQ.
Okay. Very good, though. Alright, guys, so here's what I can conclude. If S is halfway between P and R, okay, then I'm able to conclude that QS is the perpendicular bisector, not the angle bisector. Right? Everybody got me? I'm not talking about the bisector of PQR. That's not what my theorem says. Got me? If you struggle with it, look where the 90-degree angles are. Perpendicular bisectors will always form 90-degree angles. Angle bisectors, though, have the right angles where the outside angle is going to meet the bisector itself. Okay? Y'all see that? I'm not forming a 90-degree angle here. Okay? Everybody got me on that? Maybe? you'll conclude, you'll get it down. 3 minutes, 45 seconds of a break, and we'll get back to this. This problem asks me to do the following. It says, write an equation in point-slope form for the perpendicular bisector of the segment with endpoints of C at 6, -5, and D at 10, 1. Right? What is point-slope form? What is point-slope form?
The midpoints. No, it's like the points of whether or not they're positive slope or negative
Point
slope.
on slope.
Right?
Point-slope form, Faith. You need to look it up?
No.
Oh, no.
No.
Point slope. Oh yeah, it is. Looking down at it. Point slope form, guys. Anybody? Equation of a line?
The positive slope or negative slope? Points of it?
Y
The beginning point of
equals
Oh,
M
X plus B.
X plus B. So that gets me the next thing I need to do, which is do another lesson on slope formula. But we'll do all that, or I'm sorry, the equation of a line, but we'll do that later. Hey, when I find the perpendicular bisector of a line segment, or we'll also do this with the side of the triangle. It's really a 3-step process. Okay? I know, plot the points. That's not included in my step. But if you want it to be, then it's a 4-step process. Here is point number 1. Find the midpoint of CD. The midpoint of my line segment. How do I find the midpoint again?
Oh, I know this. X1, X2, over 2, then XY. I mean, Y1.
If you don't have that written down, here's your next chance to write it down. Because again, it's not on your formula sheet. And I don't have sympathy for people who don't write it down. They just fail. So, there is your midpoint formula. I have to plug my coordinate points in. We'll make it real easy. Here is x1, here is y1, here is x2, here is y2. Makes it really, really easy, doesn't it?
Sure, Mr. Hobbs.
Okay, good. 6 plus 10 divided by 2, -5 plus 1
-4.
divided by 2. 16 divided by 2 is 8. -4 divided by 2 is -2. So my midpoint is at the point 8, -2. Here's your visual. A 1, 2, 3, 4, 5, 6, 7, 8. A 1, 2. 8, -2 is the midpoint. That's the easy part. Here's just a minute. What is it?
I was thinking,
Sure.
if you find a midpoint like that, can you just count like to see like you know how like
Just find the middle.
yeah like the mean where you go like this on the middle. Yeah, that's what
1,
I did.
2, 3, 4, 5, 6.
Yeah, you three on each side of that middle.
You could, but the problem with that is when you're looking at this in a coordinate plane, it's hard when it's not on the same X or Y coordinate. Okay, I would tell you to do that, like if this was just a horizontal line or a vertical line, or a side, you know, I would tell you to do that. And just say, guys, just go halfway between the points. It gets tougher whenever we put lines in coordinate planes, though, okay? That's why we do it with the midpoint formula. Sometimes it's easy, it's a whole number, right? Sometimes I'll give you something and the midpoint will be 1 3/4, 6 5/8.
So it'll be like a whole number and a decimal.
Yeah, it can be like that, okay? Good question. Second question I got for you, Brianna. What's my slope formula? I'm waiting on you. What is my slope formula? It's in your notes.
Yeah, what we were moving on.
Oh, I'll wait.
No, it's okay, now you got it.
What is it? Waiting on you. Slope formula.
Not the y's and minus x's.
Do what? Minus the y's minus the x's. Y minus x, x minus y.
Okay.
What is the slope formula? You got it written down. I know you did. It's in your warm-up.
Yeah, I can't find my
Oh.
Oh, there it is.
Go ahead. Tell it to me.
Y2
Yep.
minus y1
Over.
x2 minus y1
Minus x1.
x1. Yeah, that's what it said.
All right, very good. So your slope formula should look like that. All right, y2 minus y1 over x2 minus x1. Let's do that here. Let's find out what our slope is. Okay? y2, 1 minus y1, negative 5. Whoa, boss! 1 minus negative 5. What do we do?
Plus.
Add 5, right? 1 plus 5 over x2, 10 minus x1.
6.
Good. Okay,
4.
here we go.
6 over 4.
6 over 4, correct?
Yes.
Close enough. If we wanted to simplify that fraction, what does it become?
3 over 2.
It becomes 3 over 2. Now, that is step 2. Here is step 3, which I assure you, you've never done before. Okay? You take your slope.
Divided.
What's that? Okay, good. You take the opposite reciprocal. Y'all have?
I've heard that word.
Reciprocal. You take your opposite reciprocal slope. When I say opposite reciprocal, let's break it down. Opposite means change from positive to negative or from negative to positive. In this case, the slope was positive, so it will now become what? Negative. And then you take the reciprocal. Reciprocal means to do what to a fraction? Yeah, I hate that. You flip it. Guys, your numerator becomes denominator, denominator becomes numerator. So this opposite reciprocal slope is negative 2/3. You've got your midpoint, and you've got your opposite reciprocal slope. This was rise over run, correct? So check it out. If I do a rise of 2, I do a run of, good, 3. 1, 2, 3. Right there. If I do a rise of 2, I do a run of, good, 1, 2, 3. Okay, and that line right there would be my perpendicular bisector. Are you with me? Okay. Midpoint, slope, opposite reciprocal slope. Okay? We found the midpoint, 8, negative 2, correct? We found our slope, 6, 4, which we turned into 3, 2. Write this part down right here. The slopes of perpendicular lines are opposite reciprocals. You can not write sense. Okay? These slopes of perpendicular lines are opposite reciprocals.